Hello students, good morning. Last classes I explained about process. What is a process? How process states are there? That I explained in last class. So how process can work with the context switching? Actually, not only one process, there are many processes are there in the system. So these process have performing the context switching. See, one process after executing the next process, after completion of that process, it gives chance to the next process. That is the concept of the context switching. So now in this lecture, we discussed about what is context switching and process, and a process consists of threads. What are the various threads involved in the process that we seen in this video? Okay, process, how we discussed about process, how process ID, process state, process priority, accounting information, program counters, CPU registers, process control block pointers, list of open files, and process input output status information. So all these things are called the process control block. This is the figure of the process control block is a data structure that store information about a particular process. This information is required by the CPU while executing the process. So the process control block has been involved and performing various activities inside the process control block. So process ID, I explained in detail in last video what is process ID, how process states has performed in the process state chart diagram, new state, ready state, running state, and waiting state, and then it is blocked state, and then terminated state. That can decide process state and priority of the process. What is the main priority? That information that contains process priority and accounting information. And then what is the main purpose of accounting? When the process, that information is created, date, time, and updated, modified, everything. So program counter. So what will be the next instruction it going to be executed? That information contains the program counter. And CPU registers. There is high-speed memory internal to the CPU as performing many operations that consist of the information of registers. And every process control block having a pointers, and then list of open files and status information and many more. It contains process control block. So process control block. Then that switching. Actually, this is a process control block. Then comes to context switching. Context switching, the CPU to another process requires performing a state save of the current process and state restore of a different process. This task is known as context switching. Context switching time is pure overhead because the system does not as useful work while switching. Context switching speed varies from machine to machine depending on the memory speed, the number of registers that must be copied, and the existence of a special instruction. Typical speeds are few milliseconds. Then that actually the current process state save and state restore. There are two processes of the context switching. One is state save, another one is the state restore. There is a many process. There is a process in the list. It is going to the state save. One is state save. One is go to the state restore. Thus context switching speed varies from. It is not only depends from one machine, and it varies from machine to machine. So one process is in the state save state, and the process is going to be restore state. That is the actually the switching can be takes place. I can explain in my next slide. This slide is the figure of the context switching figure. This figure gives the process P1. Process P1 wants save state into the process control block 1. Then interrupt or system call. then it go to the restore state in the process control block 2, then interrupt or system call, then it go to the executing state, then save state, it goes to the process control block 2 and restore state from process control block 1. There are two processes there here. There is a process 1 and process 2. Suppose it may be a process 1, it comes, this go to the process 2. One process 1, once a system call comes, interrupt to the system call comes, it go to the state, it is a save state, it is going to be save state. Then again it go to the restore state, restore state, restore state. Then after the CPU is going to be idle time because it gives chance to the next process. Then process is going to be execute for process 1. Process 1 is completing executing, then it going to chance to process control block. Then again there is an option save state, again it go to the chance restore state, restore state. Then again it keep it, again it going to be executing state, it will be executing state. So it keeps on executing for process 1 to process 2. This is the figure of the context switching, how context switching executing, and this diagram shows. Actually, this entirely, this process 1, process 2 are executing in the CPU, central processing unit. See how the process 1 and process 2 comes at a time. Process 1 comes at a time and process 2 also comes at a time. Then process 1 starts from the execution, then process 2 also starts from the execution at a time. Process 1 and process 2 executing parallelly. Then it goes to the execution. So consider the process 1 is initially running on CPU for the execution of its task. At a very same time, process P2, another process, is in ready state. If an interrupt has occurred or if the process needs input output of the process P1 would switch the state from running state to waiting state. Before change the state, the P1 process context switching helps in saving the context of the P1 process as registers along with the program counters to process control block 1. Then it loads to P2 process state from its ready state of process control block 2 to its running state. Actually, this figure gives what is the process and what is the process inside. There is many threads. A process can be thought of as an program execution. A thread is the unit of execution within the process. A process can have anywhere from just one thread to many threads. A thread is having a process. It is a continuous process. Thread 1, thread 2, thread 3, thread 4, thread 5, or many more threads consist of many more threads inside a process. So one process running, what happened means that inside threads are also running. These are cyclic action. So thread is also a dispatchable executable unit. Dispatchable executable unit inside the process. Those are also running inside the process. A processor can have many threads, or one thread or many threads. It is executing the threads in cyclic action. Actually, process versus thread. So this is the process state chart diagram I seen in the right side. Process state chart diagram. Process states the new state, then it is ready state and running state and waiting state and terminate state. When a process executes, it changes the state. The state of the process determined by the current activity of the process. Each process may be in one of the following state. The process is, then it's the state. We will discuss in detail about the state. The process is being created, that is a new state. The process is being executing, that is running state. The process is waiting for some event to occur, that is waiting state. The process is waiting to be assigned to a processor, it is a ready state. The process has finished their execution, it going to be terminate state. This is the starting state, new state. Once a new state is admitted, it going to be ready state. Then ready state is the process waiting to be assigned to a processor. Then it's going to be running state. Once it is in running, it is nothing to be interrupted. It going to be exit. It going to be terminated. Is any interrupt again it going to be ready, or again some input output event occurs, it going comes to the waiting state. After completion of waiting state, it going to ready state. This is the cyclic action running the process. This is called process life cycle. This is called process life cycle. Then what is a thread? Thread is a sequential flow of tasks within a process. Thread in operating system can be of the same or different types. Threads are used to increase the performance of the application. Each thread has its own program counter, stack, and set of registers. But thread is a single process, might share the same code and data files. Thread are also termed as lightweight process, as they share common resources. Means that a thread is also contains a block, thread control block, like how process contain process control block PCB. In the same way, thread is also contains a thread control block. In this thread control block, again it consists of program counter and then stack. Thread consists of stack and set of registers. It consists of registers and many more that contains a thread. That's why it is called thread control block. Each thread has its own program counter, stack, and set of registers. That's why thread is also called lightweight process, as they share common resources. Means that common resource consists of the process and thread that can share both process and share simultaneously. That's why thread control block. It is called having a thread control block. So this is the difference. A thread is a process consists of a thread. This is the main difference. The process versus thread is a lot of meaning has consist of a thread. Coming to process versus thread, one example we will discuss. That while playing a movie on a device, the audio and video are controlled by different threads in the background. Let us take an example of human body. A human body has different parts like hands, ears, eyes, nose. So, but functionalities which are working parallelly. So, similarly, in computer also, a single process might have multiple functionality running parallelly, where each functionality can be considered as a thread. So this example I like very much. Means that a process having a human body is nothing but a process. This is the human body. Human body as a process. A process consists of a threads like ears, eyes, nose, hands, legs. These are working parallelly. Then human also working. Without these hands, legs, nose, eyes not working, human cannot walk. So that in human body, every parts can working. So human also working. So the parts and functionality of each part is a threading. The functionality of each part is a thread. Then automatically human also can walk. That is the main example given here. So this is the difference between process versus thread. So this is one example giving the complete information about the process. That's why as a technical example, movie on a device, the audio and video are controlled by different threads. Like audio is a thread and performing, then a collection of number of frames are moving continuously. Then only we will see the movie. Otherwise, without audio, you can't see. So that is a threads, many threads running inside a process. Okay. Then mainly the process versus thread. Actually, a process consists of a rectangular box I showed here. This is a single thread process. In single thread process, there is only one thread inside the process. Actually, this thread consists of stacks, registers, coding, data, files. Let me take this is a thread control block. Let me take thread control block or process control block or both are consist of a process. This is a process entirely. This is a circle. Inside circle there is a thread. Let me consider like that. Inside a process there is a thread. Inside the thread there is only one thread. It consists of a single threaded process. Means a code, data, files, everything consists of that is a thread control block. That thread control block, even one thread consists of that is a single thread process. Even many thread consist, it become a multi-thread process. Multi-thread process consists of many threads. Register stack counter as one part and register stack counter one part and register stack counter is one part. There is every coding section, data and files are different. Even one thread should be consist, two thread it consisting of three threads or many threads. So it become consist of it is a multi-thread process. Each process have its own register, its own stack and own counter. So here second process method also register, stack and counter. The third also it have registers, stack and counter. So every thread it will be having its own register, stack, counter. But all common is code, data, files. These code, data, files involved having a process activities. That's why those are common. Code, data, files have common. But each thread have different registers, stack and counter. So that's why this is it may be considered this is a one thread control block. This is a one thread control block. This is a one thread control block. Thread control block is individually different from each thread. So here single thread control block, this entirely a single thread control block. In a single thread process, only one thread control block. In multi-thread control block, in n number of threads are there, n number of control blocks are there. Here three threads are there, three control blocks are there. So 1, 2, 3. So like that, if there is a n number of threads are there, n number of thread control blocks are there. That's why it is called multi-threading process, multi-threaded process. So process, this is versus the thread. So in this video, I explained about what is a process and what is a thread and how process perform the context switching. So context switching takes place many number of process, but process consists of many threads. A thread is a lightweight process. A process of performing context switching with the number of process, one process as executing, then it has state save, process, state save and restore activity. State save is one and perform restore, then CPU going to idle. Without performing as a multi-programming, CPU does not idle. Immediately give chance to the next process. That process going to state and go to restore space. It gives the next process. It keeps on executing in multi-programming. CPU does not idle. This is called the process. This is called the process context switching process. And a process consists of many threads. And how the threads are performing we seen in this video. As a thread control block. In thread control block consists of register, stack and counter. If one thread consists of single thread process, if many threads consist of, it is called multi-threading process. As seen in this video, we seeing the thread process versus thread, and then the references I've drawn these figures with the books of Albert Scraps, Silbert Scraps, Galvin book and William Stallings book. I drawn these diagrams. These diagrams like process control block diagram and single thread process diagram and multi-threaded process diagram. I collected in the books Silver Scraps, Galvin and William Stallings. Thank you for listening this video. Thank you, students.
Like, share and subscribe. Hit the bell icon for more updates.